I call this last section putting it all together. There was so much information. We could have gone into such detail. But what I try to do is give you the overview and the methodology you need to solve problems. So if you think about a titration, we really do have 4 different regions. We have the initial, we have excess acid, we have an equivalence point, and we have excess base. What I'm going to do is label them for you on the pictures that are in your textbook. I normally draw them out, but online it's just so different. What you need to be able to do is to compare weak versus strong, acids versus bases. You need to know that we can find Ka from a titration because that is the pH at the half equivalence point. There will be choices you need to make about indicators, and then just a word or two on polyprotic acids. So again, this is more of an informative, factual part of the lecture. That's the best way to put it. Strong acids versus weak acids. You should be able to see the difference between the 2 curves. Here we have the curve go sharply up, quickly across. Here we have a more gradual slope and a slower area for the equivalence point. The thing to note is here the pH is always equal to 7. Here the pH, it will never be equal to 7. So again, lots to tell you, but if you were to look at it at the first point, that is what you should see. What would you see after that? Well, you have to be able to distinguish where are there ions and where are there molecules in my strong acid versus my weak acid. My initial point, it is primarily H plus that's going to determine the pH. In the region here where we have excess H plus, you need to find out what is the excess. Take the moles, divide them by the new volume, and come up with a pH. That's what happens with a strong acid. At the equivalence point, as I said, look at the products. And I think the one we had was 2 times 12 is 24, 3 times 8 is 24. When your moles of acid equals your moles of base, that's the equivalence point, and pH is equal to 7. So again, it says here H plus is completely neutralized by OH minus. You'll say, I don't want to do the numbers. Well, you know, maybe you don't have to, but you do have to understand what is happening, okay? And finally, in this last region, we have our excess OH minus, and that is where we would then take our moles of OH minus and divide it by our new volume and come up with eventually our pH. All of that is for a strong acid. So we really do have just ions when we're working with strong acid and strong base. What about the weak acid? Well, know that normally you have molecules with them. So you're going to have the same thing happening here. So take a careful look at the pictures below. For our initial pH, I always say to students, Ka comes from x squared molarity minus x, where x is going to lead you to the pH. For the area here in the middle, where we have excess H plus, you will use the Henderson-Hasselbalch because you will have both the weak acid as well as some of the conjugate base. All right, got to use the right terminology. When you're at the equivalence point, hey, your moles of acid will equal your moles of base, but what you will have is A minus, and you will use the Kb of A minus equals x squared molarity minus x, and that will then lead you to your pH. Finally, when you're in your excess base, it is just like our strong acid, strong base. So again, lots for you to grasp here because titrations are very important. In upper level classes, they may be only the first 1 or 2 pages of your textbook. So we're really trying to give you a background here. The time you invest is well worth it because you're building also thinking skills. Okay, so that was long, but again, it is all sketched out for you, all the different regions, and please pay attention to this bottom area. I know you can read, so take a look at whether it's ions or it's molecules. What else do we want to say? Well, the big one is the relationship of Ka to the pH. And by that we mean if we have a weak acid, it does dissociate. When we do a titration, we are actually able to determine Ka by experiment, by doing a titration. And that is the trend. That's why there's a picture in your textbook. Next, how do you choose an indicator? Well, we've danced around it for the last couple of sections, but essentially it is a color change. You have one color and you have another color. The indicator is present in very small amounts, and what you do is you see as you do the transition. What does that mean in English? That's what the next slide is about, okay? So if you're going to do a strong acid, strong base titration, you want to choose something where you're changing from the acid to the base form. Methyl red changes in this pH area, phenolphthalein changes in that. We tend to use phenolphthalein. It's just something that, it's by basically habit. So again, guidelines, if you're going further, you're definitely going to learn more. What if you have a weak acid and a strong base? Okay, how do we know this is a weak acid? Well, its pH starts a little bit higher than regular and we have this gradual incline. What you want to do is choose an indicator that changes color right as we're going from our excess acid to our excess base. So that is a suitable indicator, and they show in your textbook that methyl red would be a poor choice. It changes color well before the equivalence point, so it's essentially useless. Again, a contrast to help you see what's going on. What's left? Well, what if you're doing a weak base? Again, how did I know it was a weak base? The pH was up above 7. And then I saw this, kind of like a slanted line, and that would say to me weak base. I would want to choose an indicator at the equivalence point. This one is not good, but here we have our equivalence point and the indicator changes color. So as we talk about all this section, this was only titrations. Strong acids, weak acids, there also are polyprotic acids. We do these one step at a time. We used to have a beautiful lab that you guys did, but labs got cut. We used to have a course called 123 when we were on quarters. 121, 122 had lab once a week. 123 had lab twice a week. Before you scream, the lab reports were an index card, and primarily it was unknowns. I'll be honest, you either got it right or you got it wrong. So that didn't play too well with the current generation. It's kind of gone by the wayside. But anyway, if you are going to a higher level course, trust me, they will do a lot with polyprotic acids because there will be the need. I realize a lot of information. This used to also sit on midterm 2, but it got to be a bit too much. So essentially, it will be in midterm 3. Please learn titrations. I say, what if you never use them again? I don't care. But what it is, you're going to learn to think. And I think that is one of the most important things to take out of Gen Chem. Seeing material that you've never seen before, or maybe seen a little bit of it, and taking it to the next step.